Welcome to the gateway number 1, the first of our gateways. What's a gateway? Just speaking loosely, a gateway test or a gateway quiz or whatever you want to call it. The idea is this is a little topic but it's something that's really worth taking some time to get good at before you try to get too much further into your math classes and stuff. It's the kind of thing that if you know this, it'll do you a lot of good, and if you don't, homework is just always going to be a drag because you're always going to get stuck on this kind of stuff. You'll notice we have a gateway on fractions coming up, because if you have to stare at every fraction and wonder what to do, it's going to slow you down quite a bit. We have solving for x gateways. We have some other gateways. But the primary, or the first, or the very most basic of the gateways is basically knowing your numbers. Like number pairs, like here's an example done here. 24. You want to be able to split that number up into all of its factors. So notice, I like to be methodical. Methodical is kind of helpful in a math context, I think. So it's like I say, well, can I divide by 1? And the answer is, of course, 1 times 24 is 24. And then I say, well, can I divide by 2? And the answer is, of course, it's an even number. Any even number can be cut by 2. And so you go 2 times 12. Yeah, that's it. Now, if you know your times tables, you'll say, I also know it's 3 times 8. And if you know your times tables, you'll also say it's 4 times 6. And notice we're kind of meeting in the middle here. 5 times 5 is not going to work. So we're done. We're done. Those are all the factor pairs of 24. And then we've got 11 more problems on this page, which I will do these in a minute. Or not in a minute, but I'll do these in a little bit. And when you take this test, this gateway quiz, you need to find every single one. So I'm going to count how many are there, and I'm going to count how many did you find. And if you missed one, that counts as a mistake. And if you put one down that's incorrect, like maybe you wrote 2 times, 13, whatever, that would count as incorrect, and so on. So it's a matter of how many perfect responses do you have. And if you miss one, that's a mistake. If you put one down wrong, that's a mistake. So I'll have to put basically number of perfect responses all over the total number of perfect responses plus errors. Something like that in order to come up with the grade. So, but before we do this part, first of all, let me get this out of here. It kind of bothers me. I don't like messing up what are you doing? I just wanted I know what I'm supposed to do. I'm supposed to go over here. Delete. There. So before we look at this, first of all, you'll see that in the description to this video, there's a link to this very file so that you can try it yourself. You might want to do that, and you might even want to set the timer to 15 minutes, because this will be strictly timed. You'll have 15 minutes to figure it all out, without a calculator, of course. And, give it a twirl, see how close you come, and then you can come back and check and see how I did it and compare your responses, and you'll get an idea of how well you'll do on the quiz. But before I do that, I want to talk a little bit about how do you do well on this thing. Well, basically, it's knowing your times tables really well. And some people know them really well, and most people know them kind of well. Some people keep forgetting 7 times 8 is 56, for example, or that 7 times 9 is 63. There's a few people keep forgetting. If you drill these, if you know all of these, all the way up to 12 times 12 is the topic of this one. It actually says number pairs through 144. If you're really good on your times tables up to 12 times 12, this will not be so hard. Now, what you want to be able to do is somebody comes up to you and says, hey, what's 6 times 8? And boom, you can say 48. You want to have like a Pavlov dog response, or the bell rings and you drool. What's 9 times 10? Boom, it's 90. You know that. What's 4 times 5? Boom, 20. You know that. What's 11 times 11? I always take a little longer to boom, but it's a 121. And so on. You want to drill these things. And it's, hopefully by now you know most of them. If there's a few that you're rusty on, like if you're really rusty on your 7s, for example, it would be worth it. It really would, to take all of these things and just kind of write them down 7 times. Go like this. Maybe you have to start with 3. 7 times 3 is 21. And write that down 10 times. 7 times 3 is 21. 7 times 3 is 21. 7 times 3 is 21. See, repetition can help you remember a little, what is this? This is like this is just a pure fact. That's all it is. So you want to try to remember it. It is nice to have a little repetition. And writing it gets your hands on it, helps you focus a little bit. You're looking at it. You're saying it to yourself. You're getting all your senses involved. By the time you get to 10 times, you're going to be saying, you know what, 7 times 3 is 21. And then you move on and you say, 7 times 4 is 24, and so on. That's a good method to learn it. I never liked flashcards, because flashcards, there's no repetition to the flashcard. Writing it out, now that's worth doing. So I just, for reference, put 1 times 1 all the way up to 12 times 12, and there's your full times table set. I don't know if you want to use that or not, but drill those. That would be good. That would be helpful. Another thing that's helpful are there's some divisibility tests that can help you know, should I try to divide this number by 3 or not, right? Now, there's a couple divisibility tests you already know. You can divide by 2. How do you know that you can divide a number by 2? Because it's even. What does it mean to be an even number? It ends in a 0, 2, 4, 6, or 8. I should just say ends in. It ends in a 0, 2, 4, 6, or 8. No matter what the number is, 4, 7, 3, 2, 6. You say, oh, it's an even number. I can divide by 2. Yay! And then you would do it. Now, we're not going to play with numbers that are that big. But the point is, you can look at a giant number and know right off the bat, oh, I can divide by 2. Here's one that a lot of people know. Can you divide by 5? Or how do you know if you can divide by 5? And the answer is it ends in either a 0 or a 5. How do you know you can divide by 10? Because it ends in a 0, right? Those are the easy ones. Most people know those. There's some others that not a lot of people know, but man, I use them a lot, and you may too. Like 3. There's a divisibility test for 3. And how does it work? It goes like this. Add up all the digits. Can that number be divided by 3? So, for example, how about the number 472? Again, we're not going to play with numbers that are that big, generally speaking, but this is good for illustrating the idea. 472, can I divide by 3? The answer is no. Okay. How about 474? Can I divide that by 3? The answer is yes. Now, how am I figuring this out? I'm saying, well, if I add 4 plus 7 plus 2, that's 4 plus 7 is 11, plus 2, you get to 13. Does 3 go into 13? No. So it's not going to go into this either. Now, what if I add up the 4 plus the 7 plus the 4? You get 15. Does 3 go into 15? Yeah. Well, that means 3 will go into this. And if you want to put 3 into this, you can do something called short division, where you don't have to do long division. You go like this. You go 3 goes into 4 how many times? Once. And what's left is a 1. So you just kind of sneak a little 1 in there. And now you're looking at a 17. 3 goes into 17 how many times? Well, 3 times 5 is 15. So you got 2 left. Sneak a little 2 here. And then look at 3 goes into 24. 8 times exactly. So, yeah, 474 can be divided by 3. We know that because when you add up the digits, you get a 15, and 15 is divisible by 3. And then it's worth doing the work. Now, if you did this, you could have just said, oh, let's try dividing 3 into here and see if it works. But that would take a lot longer than going 4 plus 7 plus 2 is 13. No, I'm done. Don't do it. Okay. I always have to ask myself how I get rid of these. I never know. Okay, well, whatever. It's gone. Cool. So that's the divisibility test for 3. The cool thing is, it's kind of the same for 9. In other words, if you add them all up, and that can be divided by 9, then the whole number can be divided by 9. So neither one of these numbers is divisible by 9. Let's get a different color going here. Divisible by 9? Well, 13 is not divisible by 9, so no. 15 is not divisible by 9, so no. Well, what if I had, come on, Come on, stop scrolling. What if I had a number like, 477? Yeah, that can be divided by 9. You know how I know? Because 4 plus 7 plus 7, that's 11, plus 7 is 18. Does 9 go into 18? Yeah. So 9 goes into this. And if you did it, you'd go like this. You go, okay, 9 goes into 4. No, it doesn't. 9 goes into 47. Well, let's see. See how knowing your times tables helps. 9 times 5 is 45. So you got 2 left. Sneak the 2 right there and say 9 goes into 27 3 times. So it's 9 times 53. Okay. So it's a combination of knowing your times tables so that, for example, you know 9 times 5 is 45. You know 9 times 6 is 54. It helps to know all these things. But it also helps to know some of these divisibility tests. So we've looked at what now? We've looked at, not 0. We've looked at 2, 5, and 10. Then we looked at 3 and 9. So 2, 5, and 10, you're looking at what it ends in. The 3 and the 9, you're adding up the digits. There's 2 more that are useful. Let me get this stuff out of the way. I keep running out of room. Let's get this out of here. Scram. Okay. I'll tell you right now, 7, oops, come on. 7, there is no trick. You just have to do it. So 7 is one of those. 4, there's a little bit of a trick. If the last 2 digits are divisible by 4, or if it ends in 0, 0. So example, 3, 6, 9, 4, 7, 12. You can divide that by 4. How do I know? Because 12 is divisible by 4. If 12 is divisible by 4, then the whole thing has to be divisible. No matter what numbers I put over here, it doesn't matter. This whole number will be divisible by 12. Or if it ends in a 0, 0, that also works. I mean, you know that, right? 100 can be divided by 4. You get 4 quarters. 4 times 25. So that works for 4. Let's see. So that's 2, 3, 4, 5. Oh, yeah, 6. There's another trick for 6, or slight trick for 6. 6. If both 2 and 3 worked. If both 2 and 3 worked, then you know 6 is going to work. 2 times 3 is 6, right? So if 2 and 3 both work, so if it's an even number and you add them up and it's divisible by 3, if both of those are true, it's divisible by 6. Okay, let's see. 2, 3, 4, 5, 6, 7, there's no trick. 8, there's not really a trick. 9, okay, that's pretty good. That's pretty good. I like those. So if you know those tricks, remember those 3 and 9 tricks. I use those a lot. This one I use a little bit. This one I use a little bit. But these I use a lot. Plus the 2, 5, 10, of course. So it helps to know some divisibility tests. If you want to get good at this thing, it helps to know your time. It really helps to have your times tables just nailed. And then what's this say? What are we talking about down here? Well, I just want to throw in a quick sort of a motivator. I'm not sure people get enough motivation for their math, but hopefully this will motivate you. Have you ever tried to learn some kind of a musical instrument? I won't say I've succeeded, but I've dabbled with some musical instruments. My latest interest was the tin whistle. The tin whistle. Now, if you're going to start playing with music, well, you need to know notes, right? So you have to be able to memorize the notes. Now, you may have had a music class in middle school or whatever, or even elementary school, whatever, where they do the old every good boy deserves fudge, and that tells you that if the note is on the very first, I should probably zoom in a little so you can see this. If the note is on this line, it's an E note. That's a G note. The next line is a B note, and then this line up here, this line's a D note. That was a B note, D note, and then this one up here is an F note. Every good boy deserves fudge, and in between you've got face. So that's an F. The space in between is an F. The space in between is a A. The space in between is a C, and the space in between here is an E. So they give you these little tricks so that you can try to, you can sort of figure it out in a pinch what the notes are. But of course, if you're going to be playing music, you want to you just want to be able to look at that and say, oh, I know what that is. That's a B. By the way, I didn't know just by looking at it. I had to figure it out real quick. But that would be ideal, is if you just look at the note and you know what it is. It's a G. Ah, that's a G. Yay. That's a G. What's this? This is a G, right? Actually, let's figure this out. This is a G, A, B, G, I guess. G, A, B, G. And then what's this? That's a B, C, D, B, C, D. Okay, those are the names of the notes. And the other thing you want to know is, what do the notes sound like? So that's that do, re, mi song, which I don't really know. Do, a deer. I guess a do sounds like that. Which one is do? I don't even know. The other thing you would want to know and have memorized is, if you want to play a G note, well, your tin whistle's got like some holes on it, right? So which holes are you supposed to cover up to make a G note? And I've kind of forgotten. But there's certain holes to cover up to make a G note, and there's this different pattern of holes to make an A note, right? And you want to get this all memorized. And the way you memorize it is you work with it every day. And it's got to be a little painful at first, but by doing it every day, what happens is, in the end, you get so good with this stuff, it becomes natural, and all of life becomes easier. Music becomes a lot easier. As a slight analogy, typing with all fingers. Now this I can speak to. I typed with my two index fingers, until I was about 30. And I could do about 12 words per minute. And for me, I was proud. Look at this, 12 words per minute, man. Then when I was 30, I forced myself to learn it. I spent 2 months doing nothing but typing with all my fingers. And to make it fun, I was playing a game by email. But I would force myself to use all my fingers for 2 months. And by the end of the 2 months, I was like, why in the world did I wait this long to learn to type with all my fingers? Why in the world? Because now I'm like, I don't know, 50 or 60 words per minute. Nothing amazing, but a lot better than 12, right? So anyway, I'm trying to say, numbers are the notes of mathematics. You play math with number notes. So if you're going to be doing math, whatever your chosen major is, if it has a math component to it, it's a good idea to practice your scales, to know your numbers, to get good with your numbers. That way, when you look at this, you can go, Frère Jacques, dormez-vous, boogieing around here, I can sing, no, I can't. Okay, that way you look at it and you just know what it is. That's where you want to head for. So how do you do that with numbers? Well, you start by, you make an effort to memorize your times table. Once you're good, and I mean 100%, you know them all. You don't have to think for more than a second. You know them all. That's good. Those divisibility tests, mesmerize them. Those are good for you too. And then keep the calculator in the drawer as much as you can. Like when I do my checkbook, I make it a point not to use the calculator, because then that forces me to practice my numbers. And it's also good if you don't want to get Alzheimer's and stuff like that. So, okay, that was my attempt at trying to motivate you to do this kind of stuff. Let's get to the how I would do this test. So I got 15 minutes. I'm going to explain what I'm doing, and it'll take less than 15 minutes, or at least I hope so. So we've seen how to, what the idea is. Take the 29, break it up every way you can. You can always go 1 times 29. Don't forget that one. Now, if you know your times tables really well, you'll say 29. That's not in my times tables at all. I'll prove it to you. Take a quick look. You see a 29 in there? I see a 28. I see a 30. I see a 25. I see a 27. I don't see a 29 anywhere. And the reason is because 29 is a prime number. And because it's a prime number, we know we don't go any further with that. It's 1 times 29, stop. Okay, next problem, 32. Well, you can always start with 1 times 32. 32 is an even number. If it's an even number, cut it in half, always. So it's an even number, so 2 goes into 32. That'll be 16 times. Can I divide by 3? Well, remember the trick. 3 plus 2 is 5. Does 3 go into 5? No. Well, then it doesn't go into 32. It helps to know your times tables here. 4 times 8 is 32. Can you use a 5? No, because it doesn't end in a 5. Can you do a 6? No. 6 would only work, remember, if you could divide by 2 and 3, but there is no 3 here, so we can't divide by 6. 7, okay, we're getting too high here, right, because that's an 8. We can't go any higher than... We're good. We've met in the middle. That's it. Okay, 45. Well, it's 1 times 45. It's not even, so I'm not going to divide by 2. Can I divide by 3? Well, 4 and 5 is 9. 9 is divisible by 3, so is this. So I'm going to do it. I'm going to say 3 times something. Now 3 goes into 4 once, and then you'll have a 1 left. Squeeze that in, so you have a 15. You're looking at that. 3 times 5 is 15. So it turns out it's 3 times 15. Is 4 going to work? No, not for an odd number. Is 5 going to work? Times tables. Remember, 5 times 9 is 45. 6 won't work because you'd have to have 2 and 3. 7, it's not in my 7's times table. It's not in my 8's times table. I'm done. 51. Well, it's 1 times 51. I always start with that. It's odd, so I don't use a 2. Can I use a 3? Well, 5 plus 1 is 6. Yeah, I can use a 3. So it's going to be 3 times something. So do the division. 3 goes into 5 one time, and you'll have 2 left. So you squeeze the 2 in, it's a 21. 3 times 21. So there, 3 times 17. Now here's another tip. Once you've reached a prime, man, oh man, I keep getting the wrong thing here. Once you've reached a prime, you can stop. Because there's nothing else you're going to be able to do. 72, well, there's a big one for you. First of all, 1 times 72, don't forget your 1s. That would be a bummer. You'd lose if you forgot all your 1s. Sheesh. Talk about losing some points for no reason. It's even, so I'll divide by 2. So you can go 2 goes into 7 3 times, which is 6, so 1 left. 3 goes into 12, or excuse me, 2 goes into 12, 6 times. So it's 2 times 36. Cool. Does a 3 work? Yes, it does, because 7 plus 2 is 9. So I know a 3 works. So now I got to do it. 3 goes into 7 2 times with 1 left. 3 goes into 12 4 times. Look at that. 3 worked. Will 4 work? Well, we just got to kind of try it. It's even, so there's at least some kind of a chance. So if you go 4 into 7, that would be once, and you'd have 3 left. Squeeze the 3 there. Now you're looking at 32, and 4 times 8 is 32. Times tables. Cool. 5 work? No, it would have to end in a 5 or a 0. 6 work? 2 and 3 both work, so 6 will. Actually, this is a times tables. 6 times 12. If you know we times tables up to 12 times 12, you'll say, oh, 6 times 12. 7, no, that's not in my 7s. 8s, hey, that's in my 8s, ain't it? Isn't that 8 times 9? Yeah. And now you've kind of met in the middle, you're done. Cool, that was a big one. 84, never forget your 1. It's even, divide by 2. Let's see, 2 goes into 8 4 times, 2 goes into 4 twice. Does 3 work? Well, 8 plus 4 is 12. 3 goes into 12, 3 goes into this. So do it. 3 goes into 8 twice. That's a 6, so I got 2 left. So squeeze it in. I'm looking at a 24. And times tables. 3 times 8 is 24. Okay, 4 will work, because watch, 4 into 8 twice, 4 into 4 once. Okay, 5, nope, doesn't end in a 0 or 5. 6, since 2 and 3 both work, we know 6 works. So just got to do it. 6 goes into 8 once. You get 2 left. Squeeze it in. 6 into 24. Times table. 6 times 4 is 24. Okay, cool. 7. Hey, that's in our times table. 7 times 12 is 84. 8. I don't think 8's going to work. No. 9. That's not in our 9s, right? No. 10. No. We met in the middle. We're done. 87. Start with 1 and 87. 2 doesn't work. It's odd. 3. Does 3 work? Well, you know that 8 plus 7 is 15, and 3 goes into 15, so 3 goes into 87, so we got to do it. So 3 goes into 8 2 times, gives you 6, so there's 2 left. Squeeze the 2 in there. 3 into 27 is a 9. Now you might recognize this is a prime. 29 is a prime. When you get to a prime, you can stop. Okay, you can just stop. 4 to go. 91. That's a weird number. Let's see. What do you get here? Well, 1 times 91. Don't forget that one. It's odd. 2 won't work. Will 3 work? Well, 9 plus 1 equals 10. 10 doesn't divide by 3. 3 is not going to work. 4 is not going to work for an odd number. 5 is not going to work. 6 is not going to work if 2 and 3 don't work. 7, remember 7's a number that you just have to try. There's no shortcut for that one. But you try it. 7 goes into 9 once with 2 left. Squeeze the 2 there. 7 into 21. Actually, that works. Times tables. 7 times 3 is 21. Notice that's a prime, which means we can stop. So it is. It's a 7 times 13. Dig it. Dig it, dig it, dig it. 105 is 1 times 105. It's odd, so don't use a 2. 1 plus 5 is 6. 3 is going to work. Got to do it. 3 goes into 10 3 times with 1 left. Squeeze the 1 in. 3 into 15 is 5 times. Look at that. It worked. 4 won't work for an odd number. 5 works because it ends in a 5. 5 goes into 10 twice. 5 goes into 5 once. Okay. 6 won't work because you have to have 2 and 3, and we don't. 7, you just have to try 7. 7 goes into 10 once with 3 left. 7 into 35. That worked. 8 can't work for an odd number because 8 is even. No matter what you multiply 8 by, it's even. So 8 won't work. 9. Well, if you add 5 and 1, you get 6, and 9 doesn't go into 6, so 9 won't go into that. 10 won't work. 11, no, nothing else is going to work. We got nothing. We're done. 120, well, start with the 1 times 120. It's even. 2 times 60. It can be divided by 3. 3 times 40. It can be divided by 4. 4 times 30. It can be divided by 5. 5 times, let's see, 5 into 12 twice with 2 left. 5 into 20. 4 times. Erase that. I want to erase that. Okay. 6, because 2 and 3 both work, 6 works. Well, actually, 6 goes into 12 twice. Yeah, that's cool. I don't think 7's going to work. 7 into 12 once, and then you're looking at a 50. 7 doesn't go into 50. Nice. Nope. 8, maybe. Let's see. Does 8 work? 8 goes into 12 once with 4 left. So you'd have a 40, and 8 goes into 40 5 times. Look at this. Look at all this stuff. Holy cow. Does 9 work? Well, 2 and 1 is 3. 9 doesn't go into 3. 9 doesn't go into that. 10 works. It ends in a 0. 10 times 12. 11 doesn't work, and we've met in the middle, so we're finally done with that one. 1 more to go. 1 times 126. It's even. 2 times, let's see, that would be 63. 6 plus 2 plus 1 is 9, and so 3 is going to work. 3 into 12, 4, 3 into 6 twice. 4, well, you just have to... Oh, remember that trick about 4. You just look at the last... That's not what I wanted to do. You just look at the last 2. It has to go into the last 2, or the last 2 have to be 0, 0. But 4 doesn't go into 26, so I can just stop and say, no, it's not going to work with the 4. 5, no, it doesn't end in a 5 or 0. 6, 2 and 3 both... You again. 2 and 3 both worked, so that means 6 will work. Well, actually, 6 goes into 12 2 times. 6 goes into 6 1 time. 7, you just got to try 7. 7 goes into 12 once, which would give you 5 left over, and 7 into 56 times tables. 7 times 8 is 56. Cool. Does 8 work? You just have to try it. 8 goes into 12. 8 goes into 12 once with 4 left. 8 into 46. No, that's not in my times tables. 8 doesn't work. 9 will work because 6 plus 2 plus 1 is 9. So 9 has to work. 9 goes into 12 once with 3 left. 9 goes into 36. 9 times 4 is 36 times tables. 10 won't work. 11, I don't think. 12, no, that's not in our... We're done. We did it. We did the whole thing. Geez, I sure hope that was less than 15 minutes. Yeah, it had to be, right? Yep. So anyway, I hope you're getting a little bit psyched for this test. You got a week to prepare. I would start with my times tables. And once I had my times tables nailed, because how many times did I say, oh yeah, that's in the times tables? I mean, times tables are big. Divisibility tests are useful. They will make you go faster. power of every day. If this is something you really need to practice a little every day. That's how they ask you to. If you take music lessons, that's what they'll say. Practice an hour every day. It's the every day. If you practice 7 hours on Saturday, that's not as good. If you practice 1 hour a day for the week, that's much, much, much better, because sleeping in between, your brain works on it, and they've proven that. It's the sleep periods in between are massive for you. So anyway, I hope you have fun with this stuff. If you're good with numbers, all of the rest of math gets much more fun.